How to read a ruler. So you've probably noticed when you look at rulers all these little ticks. And they usually don't have numbers accompanying them. So in this video, I hope to show you what each tick means. So the rule is, if you are measuring some random measurement, like maybe I put this up against a piece of wood or something and it measured to here. You only count the lines that size or bigger. You ignore all smaller lines. So all of these lines are smaller than this. So we would only count to this. Well, there's only 2 of them, so it's 1/2. And if you count all the way to the next one, well, this line over here is obviously bigger. Well, that's 2/2, which is just 1. But what if I asked you to measure to this line? Well, again, the rule is only count the lines that are that size or bigger. Well, each one of these lines are smaller, so we'll ignore them. So we'll start here. There are 4 of these. 1, 2, 3, 4. So these are fourths. So we go 1/4, 2/4, and 3/4. And then, of course, 4/4, which is just 1. And hopefully by now you're starting to get a pattern. So what if we measured to this line? Well, again, we'd only count the ones that are that small. Well, these are 8ths. One way you could tell is it's 1/2 of a 4th, which is an 1/8. Or you could count how many there are. We would get 1, 2, 3, 4, 5, 6, 7, 8. But as they get smaller, as we get to 32s and 64s, that gets kind of annoying to count. So you just kind of figure it out by looking at the halves. So if this is 1/8, then this is 2/8. This is 3/8. And this is 4/8. Now you might notice, well, we've already named 1/8 or 2/8 and 4/8. We named 2/8, 1/4. Well, yeah, because 2/8 is 1/4. 2 is 1/4 of 8. 4/8 is 4 is 1/2 of 8. 4/8 equals 1/2. Which makes this one, we'd skip the smaller line, just like we've been doing. We skip all the smaller lines here, and we go to 5/8. And of course, this makes 6/8, and this one 7/8. We don't need to write down every single one. The point is, you see the pattern. So what if we were to measure right here? Well, this would be, we count every single line that is bigger or the same size. We'd ignore all smaller ones. Well, this is the smallest one, you might say. Well, yeah. So 1/16, 2/16, and 3/16. Well, you might say, well, I noticed a pattern here, Mr. Anderson. These are all the halves, so that would make this 8/16. This is the same. What if we were to measure to here? Well, I could start from the beginning and count 1, 2, 3, but I'm already bored counting. I could say, well, this is 8/16, and this is one more, so this one has to be 9/16. And yes, it always works this way. What about over here? Well, again, you don't have to count all of these. You don't need to count all of these. You could just count from this end. This is 16/16. So this is 15, 14, 13/16. And you might say, well, this just seems like simple math or simple counting. And the answer is yeah. It turns out math always works, even when you are measuring with a ruler. So this ruler doesn't have 32s of an inch, but you could imagine what it would do. In fact, we will. We'll go ahead and make even smaller ticks right here. And go ahead and follow along with me and make all your smaller ticks. Well, as you might have guessed, these smaller ticks are 32s, which makes the halfway mark 16 32s. And you might ask yourself, why don't we just call this 16 32s? Why do we call it 1/2? And the answer is, it's simpler. In fact, that's where the term simplify comes from with fractions. Because it's a lot easier to say this is a 1/2 inch than it is to say, oh, how far along the way is this? Well, it's 16 32s. Well, you have to think about it for a second before you realize that's half. 1/2 inch is just simpler to say. So what if I ask you to measure to this? Well, you could count all of them, 1, 2, 3, 4, 5, 6, or you could realize that this is the end, which makes this 32 over 32. And this is one less than that. So again, it is simple math. This is 31 over 32. Well, what about this line? Well, again, we could count from either end, or we could start right here. We know this is half, which makes it 1632s, which makes this 1732s right here. And we won't go into 64s, but hopefully you see that there's a pattern here and that it would work the same. But with that in mind, I wanted to talk about converting fractional inches into decimal inches. So half would always, or obviously, be 0.5. We wouldn't even have to do any math to figure that one out. Well, hopefully you don't do any math to figure out a quarter, but if you do, you could just divide by half. Well, half of a half is 0.25, or 25 cents for a quarter. Well, an eighth would be half of that. Well, I've always been bad at math, so we can figure this out. What's half of 0.25? So what's 0.25 divided by 2? It'll be 0.125. Let's double check our math. What is 1 divided by 8? Let's see if we get the same answer. And yes, we do. So this is 0.125. Right here, this line. This line is 0.25. And so, yeah, it doesn't matter if you're cutting these in half, which they are, or we're cutting these in half, and then we're doing the math. Plug it in our calculator. We will get the same answer. And so hopefully you see how easy it is to turn these into decimals. I could just divide these by 2 because that's what they're doing. They're cutting in half. Or I could just type the fraction into my calculator and I will get it. 1 divided by 16 or 1/16 is equal to 0.0625. 0.0625. And I just wanted to make that look a little bit nicer there. Now, what if I asked for the decimal inches of this length here? Well, what you need to realize is this length from here to the beginning, here to here, well, that, if you really look at it, is just this length plus, well, let me get a different color here, plus this length. We're just adding those up. Well, this green length is 0.05 or 0.5, I'm sorry. And this sort of little blue length right here, well, that's 0.0625. It's the same as this distance. So I basically just add up those numbers. And so I get 0.5 plus 0.0625 would give me what? 0.5625. We can see it, that's right. Let's fix that arrow real quick though. So we draw this straight line and we draw a little triangle pointing towards our little thing, and it's not perfect, but we can move on. Well, if we look across the aisle, that's 9/16 here. So let's see what happens when we type in 9 divided by 16. Let's see if we get the same answer. And of course we do, because it is 1/2 plus, well, 1/16. And then 1/16, or 1/2, I'm sorry, is the same as saying 8/16. Well, 8 plus 1 is 9/16. And so, yes, as you can see, math always works here. And there's one more way I could think of it. I could think of it as, well, there was 9 of these. There was 9 of this 0.0625. So I could type that on my calculator. I could say 9 times 0.0625. And if math really always works, then these numbers, or this times 9, if there's 9 of them, will end up being here. And let's see if we're right. Let's hit enter. And yeah. And that's how reading a ruler and reading fractional inches work.